In linear algebra, eigenvalues are scalar values that represent how much a linear transformation changes a vector. For example, consider a matrix A that represents a linear transformation and a vector V that is transformed by A. If the transformed vector AV is a scaled version of the original vector V, then the scalar is called an eigenvalue of A. Mathematically, this can be represented as AV equals lambda V, where lambda is the eigenvalue. To find the eigenvalues of a matrix, we need to solve the characteristic equation, which is obtained by setting the determinant of A minus lambda I equal to 0, where I is the identity matrix. Let's consider a simple example. Suppose we have a 2 by 2 matrix A with elements A, B, C, and D. The characteristic equation for this matrix is obtained by setting the determinant of A minus lambda I equal to 0. This gives us the equation lambda squared minus trace A times lambda plus determinant A equals 0, where trace A is the sum of the diagonal elements of A, and determinant A is the product of the diagonal elements minus the product of the off-diagonal elements. For instance, if A has elements 1, 2, 3, and 4, then the characteristic equation becomes lambda squared minus 5 lambda minus 2 equals 0. We can solve this quadratic equation to find the eigenvalues of A. Using the quadratic formula, we get lambda equals 5 plus or minus the square root of 25 plus 8, all divided by 2. Simplifying this expression, we get two possible values for lambda. These values represent the eigenvalues of the matrix A. In general, the eigenvalues of a matrix can be real or complex numbers, and they can be distinct or repeated. To visualize the eigenvalues, imagine a graph where the x-axis represents the real part of the eigenvalue, and the y-axis represents the imaginary part. The eigenvalues of A are plotted as points on this graph. For a 2 by 2 matrix, we have at most two eigenvalues, which can be real or complex conjugates. Understanding eigenvalues is crucial in many applications, including stability analysis and Markov chains. Continue asking questions about eigenvalues to explore more topics and examples.